Section 4.1, Exponential Functions. If you look back at our previous chapters, most of the things we worked with were something like an x squared or an x to the fourth or something like that, which means our base was the variable and the power was the number. But if we're going to switch to defining an exponential function, that's where these are going to switch. So your base is going to become the number and your variable becomes the power. So the exponential function with base b is denoted by f of x equaling b to the x, where b has to be greater than 0, but b cannot be 1. And now x is a real number. So b is going to be the number, x is going to be the variable. So your base is now the number and the exponent will be the variable. Why can b not be 1? Because 1 to any power just gives you 1. So that's the reason why b has to be greater than 0, but can't be 1. So let's just make sure we can evaluate an exponential function. So if I wanted to find f of 2, that means I would have 3 squared. And 3 squared is just 9. If I wanted to find f of negative 2/3, well, that would be negative 2/3 power. So plugging that into our calculator, we would have 3 raised to the power of negative 2/3, which gives us approximately 0.48, and we'll round to the thousandths place, so for 0.481. So this would be approximately 0.481. So you can do the other ones, but I'll go ahead and give you the answer. So f of pi would be 3 to the pi, which is approximately 31.544. And f of the square root of 2 would be 3 to the square root of 2, 0.729. So again, just making sure we can do some evaluating. Now let's look at the graph of an exponential, since we haven't really seen a graph of an exponential. So back in the day, we always said if we didn't know what a graph looked like, the best thing to do is just to make a table. So let's plug in negative 2, negative 1, 0, 1, 2, and let's just go ahead and go on to 3. So if I plug in a negative 2 for x, I get 2 to the negative 2, which is 1 over 2 squared, so I get 1 over 4. If you want to plug that into your calculator, you can do so. And when you say 2 to the negative 2, you're going to get a 0.25. This handy dandy math key is really going to be important. Hit your math key, that'll say fraction, hit fraction, enter, enter, and it'll change it back into the 1/4. So 2 to the negative 2 is just 1/4. 2 to the negative 1 would be 1/2. 2 to the 0 power, well, anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. And 2 to the third power is 8. So negative 2, we're at a 1/4. At negative 1, we're at a 1/2. 0, we're at 1. 1, we're at 2. 2, we're at 4. And 3, we're at 8. So we see that exponential graphs start going up quickly, and they are never going to pass the x-axis, so you have a horizontal asymptote on the x-axis. Now, where are things in the real world that do this? Well, right now, the coronavirus is doing this with the number of infections. Where else could we see this? Well, sometimes the stock market does this, but not right now. Population, you know, we're not going to get into how the world began, but there were some people, and then there were more people and more people. So a lot of this represents, again, population. Let's go ahead and look at our domain. So from left to right, we're including all these points. So our domain is going to go from negative infinity to infinity. Our range says go from bottom to top. Well, down here we don't hit anything till we get to, now a lot of students want to say 1, but if we do 1 and above, then we're losing all of that piece below in between 0 and 1. So we actually need to start at 0, but not including the 0. So our range will be 0 to infinity. Our horizontal asymptote is a horizontal line, so it's going to be y equaling 0. And the y-intercept crosses at 1, so my y-intercept is 0, 1. So now let's see what happens if our exponent is a negative x instead of a positive x. So we're going to do 3 to the negative x. Again, when we're not sure what it looks like, let's go ahead and just make a table. let's go ahead and plug in just -1, 0, 1, 2, and 3 to save a little bit of time. When I plug in a -1, well, 3 to the -1 and a negative make a +1, so I just end up with 3. Anything to the 0 power is 1. Now when I plug in a negative over 1, I get 3 to the -1, well, that's 1/3. And if I do 3 to the -2, well, that's 1/9. I'm kind of going the wrong direction. So maybe instead of going higher, I should go lower. So let's change this to -2 and say -3. So when I plug in a -2, well, 2 negatives make a positive, so I get 3 squared, which is 9. And when I plug in a -3, I get 3 cubed, which is 27. So what's this looking like? Well, we have -1 is at 3, 0 is at 1, 1 we have 1/3, and then we're going to get really close to that x-axis. At -2, we're all the way up at 9. So hopefully you see that this graph looks something like this, and again with the asymptote on the x-axis. It doesn't stop, it just continues to get closer and closer to that x-axis. So I'm going to let you fill in the domain, the range, horizontal asymptote, and y-intercept, and hopefully you'll see that all of this is the same as previous page. So make sure you understand that actually nothing really changed even though it flipped over the y-axis. So let's now talk about the transformations. So we had transformations in previous chapters where we talked about going up, down, left, and right. And the way we knew that is if it was in parentheses or outside parentheses. So let's see what's happening here. If we have y equaling, let's clear that out, and we'll type in 3 to just the x. So let's go back to a parent function without the +2, and we have this as our graph. Now it kind of looks like it stops here, but that's just because it gets too close to the x-axis, so you can't see it anymore. So make sure you understand that it really does continue following that x-axis. What do you think the +2 is going to do to everything? Well, it's either going to move it up or it's going to move it to the left, because we learned from our previous transformations that we know what's happening up, down, left, and right. Well, let's see what happens with the +2. It's in a sense like going with the parentheses, so that would move everything to the left too. So the asymptote goes left too, which doesn't really make much difference, but then every point goes to the left too. So let's see what happens when we have y equaling 3 to the x plus 1. So again, we're going to take this off. Outside the parentheses we have a +1, so hopefully you realize that it's not going to go left or right, but it's going to go up or down. There's my original. The +1 moves everything up 1. Now remember, since it got moved up 1, so did the asymptote. So now the asymptote is at y equaling 1. It's not at y equaling 0. So let's go ahead and say what's happening with the plus and the minus. So when you're with the x, that's like with parentheses, so it's opposite of what you think. So you're going to go left if there's a plus sign, and you're going to go to the right if it's a minus sign. But again, it has to be with the x. When it's not with the x, that's going to shift it up if it's positive, and down if it is negative. So let's see if we can understand what's happening to number 4. F of x equaling 2 minus 3 to the x. Let's go ahead and rewrite that with -3 raised to the x plus 2. Just to point out, our b is not negative because it's 3 to the x and the negative's on the outside. It's not in parentheses, so understand that. So what's going to happen first? Well, according to order of operations, we're going to do the minus thing first. That would be the first step. It's not with the x, so it's again messing with the y's. So if it messes with the y, it reflects over the x-axis. And then step 2 would be the plus sign. And what's the +2 going to do to everything? It's going to move up. You're asked to graph that. Alright. So the next thing is this thing called the natural base. Something you're definitely going to want to remember. It's hugely important in the next couple of sections. So when we talk about the natural base e, yes, e is a number, also a letter, but now it's going to be a number. Where does e come from? All kinds of places, but one place is if we take this function and when we let x get really, really large. So if I just put in a 1 here, I'm going to get 2. If I put in 100, I get 2.7 continuing. And if I continue this process and I put in 1,000,000, well, this function starts going towards a number that is an irrational number, and we call it e. So as n gets really large, f of x approaches e, and e is approximately 2.718. So I want you to remember what e is approximately, and we'll always say about 2.718. Just like if I asked you what pi was, most of y'all know that pi is approximately 3.14. So now when I say what's e? E is approximately 2.718. But the great thing about this is if you forget what e is, it's in your calculator. And where is e? The one I like is above the ln. It's e to the x. So you could bring up your e, and then you just want to know to the first power, what is it? And you'll see that it's approximately 2.718. So you can always know what e is by just looking in your calculator. So this number is called the natural base. Hugely important for you to remember. That's called x equaling e to the x is called the natural exponential function. So again, just like if we are not knowing what any kind of graph looks like, let's plug in a couple of numbers. We'll plug in a -1, 0, 1, and 2. So when I plug in a -1, I get e to the -1. And then I'll get e to the 0, e to the first, and e to the second. Well, what is e to the -1? So we bring up our e again. Again, it's above the ln. And we're going to plug in a -1. And e to the -1 is approximately 0.368. Well, you know what e to the first power is because anything to, e to the 0 power, because anything to the 0 power is 1. We also know what e to the first is because we just had it up here. E to the first is approximately 2.718. So approximately 2.718. And then we want to know what e squared is, so we'll bring up the e again, and we'll type in the square. So we'll bring up e, type in the square, and we get approximately 7.389. So e squared is approximately 7.389. That's where we get this graph. Here's 0, 1, 1, 2.7, and 2, 7.3. Again, our asymptote is right on the x-axis. So, what if I asked you to graph h of x equaling negative e to the x minus 2? I don't want you just grabbing a calculator. That doesn't help you. You need to understand what is happening with the transformations. So, let's go ahead and just graph our basic parent function, which is e to the x. So we're going to use the points that we just got right above. So 0, 1, 1, 2.7, and 2, 7.3. So we'll just plot those 3 points, knowing that our asymptote is on the x-axis. So what are the steps that are going to happen? Well, the first step is the negative, and so that is going to be a reflection. So reflect over, and that's going to be on the outside, so it's messing with the y's, so it flips over the x. So this point was 0, 1, so flip it down. This point was 1, 2.7, so we're going to go 1, negative 2.7. This is 2, 7.3, so 2, negative 7.3. So just with the negative, which flips it over the x-axis, now my graph does that. And then the last step, step 2, is going to move everything down 2. Sorry, so down 2. Don't forget to move your asymptote. So your asymptote goes down 2. And now every point goes down 2. 1, 2, 1, 2. And kind of off the graph. That's okay. So here's your final graph with the transformation. If I asked you what the domain is, the domain is still negative infinity to infinity. But the range now goes from negative infinity up to negative 2, and negative 2 would have a parentheses.